Has everyone joined? Shall we start the class? Or any more have to join? So I want some response from you people.
I think we can start.
Okay. I think we can recall what we discussed in the last class regarding formation of jet stream. We saw how the height of air column over a cold region and warm region varies. So on any constant pressure surface, 850, 500, 700, whichever pressure surface you take, it will not be horizontally at the same height. Where the air is cool, the pressure surface will be at a lower height. So that means what? In a constant pressure chart, you will draw isolines of constant. What will you draw? In constant, okay. At a constant height, at surface level, what do you draw? Isolines of constant for analysis. What?
Isobar, ma'am.
Isobars, good. That is isolines of constant pressure. Now, each line is actually a line of uniform pressure, isn't it? Mean sea level pressure. Each line is a line of uniform pressure. Likewise, if you take constant height chart, you will draw isolines of constant pressure. If you take a constant pressure chart, you will draw isolines of constant.
हो गया हाँ हो गया रूम में कहा कराता हूँ
Height, because height is only going to vary, isn't it? The pressure is remaining constant. 850 HPA means everywhere pressure is 850 HPA, but the height is going to vary. Over the cold regions, it is going to be at a lower height. Over the warmer regions, it is going to be at a greater height. So what we will draw are iso lines of constant height in constant pressure chart. Okay, these charts are generally known as the contour charts. So now here you see, I'm showing you the 500 HPA level, how it is at a lower height from the surface to the colder region and at a greater height over the warmer region. And we also saw at the interface of the tropical air mass and the subtropical air mass near the along about 30-degree north latitude or south, north or south. There you have two types of air masses meeting, cold air and warm air. So there you see that the cold air coming from the mid latitudes or the subtropical belt, that air mass will be at a lower height. Supposing you take 200 HPA level. So at 200 HPA level, the height of the 200 HPA level on the colder side will be at a lower height than the height of the 200 HPA level on the warmer height. So at the interface, you will have a strong height gradient. If it is a constant pressure surface, it is height gradient. If it is a constant height surface, 3 kilometers, 3.1 kilometers, 5.8 kilometers, we have some stacked heights, isn't it? So if you take constant height surface, there it will be actually what will vary now, there the pressure will vary. But here the pressure is remaining constant, the height is going to vary. So if you take 500 HPA level, there also the height of the 500 HPA level, even though generally we say 5.8 kilometers, it is not 5.8 kilometers from sea level everywhere. Over the colder regions, it may be at a lower height, say 4.7 kilometers or something. On the warmer side, it may be say 5.9 kilometers or 6 kilometers, and depending on the temperature gradient between this warm and the cold surface, the gradient may be strong or weak. So now you see, because of this strong pressure gradient, what is happening now is you find that this pressure gradient, as you go at the surface, at the interface between the cold and the warm air, there is not much difference in the height. But as you go up, the height, the difference in the height between warm and the cold air keeps on increasing. So the difference in the height gradient between the two also increases with height. Because the height gradient increases with height, the associated wind also, like if the pressure gradient force increases with height, the wind speed will increase. Likewise, the height gradient force also increases with height. That leads to the stronger winds and the upper. So as you go up and up and up, because of more and more stronger horizontal temperature gradient, you are having this stronger wind speed. So the horizontal temperature gradient at the interface of tropical air mass and the subtropical air mass, that temperature gradient increases with height. giving rise to increase in the wind speeds, geographical wind speeds with height. So this kind of increase in wind speeds leads to very strong wind speeds of the order of 100 knots or even more near about the tropical, just below the tropical tropopause. So say something like the tropical tropopause, we can say as a 200 HPA level, maybe it's 14 or 15 kilometers approximately, let us suppose. Below that, 12 or 13 kilometers, we can expect this kind of maximum wind speeds. Then further above if you go, wind speeds will start decreasing. So there is a region where the wind speeds are the maximum as you go from surface to the in the upper in the vertical. And this strongest the area of strongest wind speed is known as the region of jet stream. And so you find that at the interface of the two different air masses, that is tropical warm tropical air mass and then cold subtropical air mass, they meet at the interface of the Hadley cell and the Ferrel cell. So there, this kind of sharp temperature contrast happens, and that gives rise to this jet stream at the upper levels. This happens at upper levels, especially around 200 HPA level, just below the tropical tropopause. And we also saw why it happens like that, because you see that on the colder side, the tropopause is reached, because the colder side, the tropopause is at a lower height, say something like 13 kilometers or 10 kilometers. And on the warmer side, it is 15 kilometers or something. So once the tropical tropopause is reached on the colder side, stratosphere starts. So temperature starts increasing here. But at 12 kilometers or 13 kilometers on the warmer side, it is still within the troposphere only. Temperature keeps decreasing. So beyond the 15 or 16 kilometers where the tropical tropopause is there, beyond that only temperature will start increasing. So now if you put these two together and try to visualize, you will get a scenario of on the colder side, temperature decreasing up to 13 kilometers, then starts increasing. On the warmer side, temperature decreasing up to 16 kilometers, then starts increasing. So in between, now you can see there is a phase where the two lines cross. Beyond that, you see on the warmer side, temperature keeps decreasing. On the colder side, temperature starts increasing. And at one point, you see that the temperature of the blue line corresponding value, the temperature of the red line, see the corresponding values. The red line is at a lower temperature than the temperature of the blue line. What does it imply? That the temperature on the other side, on the colder side, is now warmer. So that the temperature gradient reverses. The warm air is on the colder side now, the colder air is on the warmer side now. So there is a temperature gradient. You can see the red on the blue side and the blue on the red side. So that's a reversal of temperature gradient. This reversal of temperature gradient gives rise to that change in the height gradient force, the direction of the height gradient force or the pressure gradient force. So which will now start decreasing it will act, this force will now reduce the winds in the particular direction. Winds are in the westerly, means this will make it easterly. So slowly the wind speeds will start decreasing as you go further up. So you will find around about 200 HPA level, just below that you will find this jet stream. So the third is the region of increased wind speed. The mid-latitude jet stream is located near about 200 HPA level. And we also saw the three-dimensional figure. On the warm side, you see the height of the air column here, 200 HPA level. On the colder side, see the height of the air column here. So this much height gradient is that. And then this is the actual axis of the jet. So this is just you don't have to remember all these things. Just for you to visualize, I am showing all these features. And then we also saw when the air is moving, within the jet stream, there will be regions of maximum, jet maxima, which some books refer to as jet streak. But generally we use the term jet maxima. So where we are having jet maxima, see you see 80 knots, 100 knots wind speeds are increasing. Here you are having the maximum wind speed. Here again you see around 100, then it will become 80, 60, like that it will decrease. So when air is coming from the west and entering towards the jet maxima, in the region where it enters the maxima, you are having the entrance region. And then when it is about to leave the maximum wind speeds, 100 knots winds is only in this region. Then beyond that it is only 80, 60, like that. So now here it leaves the maxima. So you are having the exit region. So you are having the entrance and the exit region. The entrance and the exit region, I told you, because there is a very sharp, you can say that when the height gradient is there, the height gradient becomes very, very strong here. You see how the lines are far apart here. But when it comes here, the heights are coming very close. So they are more closely packed. If they are very closely packed, then the height gradient force or approximate or correspondingly the pressure gradient force will be high. So the Coriolis force, which is the balancing the pressure gradient force for the wind to flow in straight direction, this will take some time to match the pressure gradient force. So for a very fraction of a second, what will happen? There will be imbalance between the pressure gradient force and the Coriolis force. Due to this imbalance, actually winds coming towards this maxima, they will all actually be they'll move towards the colder side. So you will find more air on the colder side of the entrance region and less air mass on the warmer side in the entrance regions. But then afterwards, when it is about to leave the jet stream, what will happen now? Whatever is extra air that was on the colder side, that will now again come back to the warmer side. So when the air comes out, it will be the same as it was earlier. So you will find when it is traversing this maxima, on some areas there will be divergence, some areas there will be convergence. More air is coming from this region and going towards this colder side, so you will have upper level convergence here. And then here, the right side, you will have upper level divergence. And when the exit side, if you see, on the left side, you will have upper level divergence. On the right side, you will have upper level convergence. So where you are having upper level divergence, right entrance and then the left exit you see here. At right entrance and left exit, where you are having upper level divergence, there, because at the upper level air is moving out, at the surface, what will happen? More air will go up, rising motion will happen. At the surface level, pressure will fall because air is rising up now. Whatever air is there in the upper levels, it has moved away. So more air is rising up. It is pulling more air upwards. So at the surface level, air is less. So pressure falls. So you will find surface pressure falls where you are having upper level divergence at the right entrance and the left exit. This is the major feature that you need not go into understand all the dynamics. Just remember right entrance and left exit at in the upper levels, 200 HPA level, there is upper level divergence due to wave maxima. So this region is now conducive for weather system to intensify because when you are having upper level divergence, when you are having and low pressure system forms in the lower levels, what will happen now? These systems will intensify because this jet maxima, the right entrance of the jet maxima provides the necessary upper level divergence for the system to intensify further. So that is what we discussed in the last class. So today we shall see different important jet streams that we generally come across in our weather analysis. So I told you two major jet streams which go around the entire globe. One is at the interface of the Hadley cell and the Ferrel cell, which is the subtropical westerly jet stream. And also another jet stream is that's also westerly jet stream. Another jet stream at the interface of the Ferrel cell and the polar cell. There you are having another jet stream. So two jet streams are moving in the globe on both the hemispheres, on the northern hemisphere as well as in the southern hemisphere. So two global jet streams, subtropical westerly jet stream, polar front jet stream. So these two are global jet streams. They will be seen throughout the year, covering the entire globe. But they will be most intense during the winter season. Can any of you guess why? Jet streams are more stronger or well defined in winter season than in summer season. Just can any of you guess? Okay, if not, let us just try to understand. During summer, peak summer, what is the maximum temperature that Delhi can experience? Roughly, you tell.
40.
45 degree, ma'am.
45 degrees. And what is the maximum temperature Chennai can experience?
25.
37, 38.
For 40, it will definitely go. 40, 42, like that. Maximum, I'm telling. Huh? So the temperature difference between the north and the south will be something like 5 maximum say 4 to 5 degrees. Go to the winter season. In winter season, what is the lowest minimum Delhi can experience?
4 to 5 degree.
Pardon?
4 to 5 degree.
5 degrees. What about Chennai?
18, 19.
Very rarely. Approximately 20 degrees we can keep. So what is the temperature difference here now? North-south. There 5, here it is 20. Approximately 15 degrees.
Yes, ma'am.
During summer season, the temperature difference between north and south is approximately 5 degrees.
5. Yes.
During winter season, the temperature difference between north and south is approximately 15 degrees. So you can see the temperature contrast between north and south is most defined during winter season. That is why jet streams are stronger in winter season than in summer season. Temperature difference between any two areas, the tropical air and then the colder subtropical air, the temperature difference between them will be maximum, or you can say the horizontal temperature gradient will be maximum during winter season. That is why jet streams are generally very strong during winter. And that's why jet streams, we discuss jet streams with the winter season. Very rarely we discuss them with the summer season. So both these jet streams are very strong during winter season. And in addition to that, we also discussed about two jet streams, if you can recall, during the monsoon, when we discussed about the monsoon season. One is the tropical easterly jet. I think this also I was mentioning yesterday. That is a jet stream that is seen over the Indian Ocean region from Vietnam to African coast across the Indian region. Then that's a very very special jet stream that forms only during the monsoon season and that too over this region only. And that is one of the semi-permanent features of the southwest monsoon. Am I right? Yes or no? Did we not discuss this tropical easterly jet when we discussed about southwest monsoon? Components or semi-permanent features of monsoon? See, I have been repeatedly telling you so that at least the terms become familiar for you. I keep repeating it. I take in one class, they repeat it in the next class, and any other context, if some in some other context also, if I can recall, I keep recalling so that the terms will become more familiar for you. Can you recall? Tropical easterly jet.
Yes, ma'am.
Okay.
Yes, ma'am.
So that is the another important jet, but that is not a global because it is confined only to this region or during a particular monsoon months only. So it is not a global feature. But that again, that has got a very very important. It is one of very very important feature with respect to our Indian monsoon. And then we also saw another. These jets, what we discussed, subtropical, so polar jet, tropical, all these are in the upper levels. But in the lower level also, we discussed one jet stream for the monsoon season. I suppose you can recall that also. Low level jet or the fin glider jet, I told you, this cross equatorial flow coming from the masculine eye. Then it is coming southeasterly trade winds. When they cross the mountains of the Africa, they rebound, become southerly, and then when they cross this Somalia coast, where you are having extensive heat flow is forming there. So because of that, what happens now? The temperature gradient between this heat flow and then the oceanic region, that temperature gradient becomes what to say amplified over this region, because of which wind speeds also increase and they attain very strong wind speeds of around 40 knots or more. So this is also called a jet stream, 40 low level jet. So this is also having a greater bearing on the rainfall. This also we discussed when we discussed about the components of the monsoon. I suppose you can recall. So basically 4 jet streams we have discussed so far. All these 4 jet streams are important with respect to the weather, which we are. Polar jet stream not much for our region, but other three jet streams for our region. So now we shall discuss one by one. So these two are the global jet streams, polar and the subtropical, and this is the tropical easterly jet stream from the Vietnam coast to African coast here. So across the Indian region, it's having maximum in wind speeds or maximum amplitude over the Indian region. It's the accelerating stage from Vietnam to the Indian region. It is having maximum speeds over the Indian region, like over Trivandrum and around that region, just extreme southern parts of India. And then afterwards, wind speeds start decreasing. See, from red to orange to yellow, you can see how the wind speeds are decreasing. 30 meters per second, 27 meters per 24 meters per second, wind speeds are decreasing. So you can see that actually it is having maximum intensity when it is over the Indian region. This is the tropical easterly jet. This is what during which months? During which months? Just now we were discussing.
April,
Pardon?
April month, ma'am.
April, what
April
is
month.
monsoon season? This is a very special jet stream which is observed over the Indian region during the monsoon season. What is the monsoon season?
Southwest
Which period?
June, ma'am.
June to
June
September.
to September. So this jet stream is seen only during June to September. You can see this chart June to September chart of 150 HPA wind. So when I plot this 150 HPA wind for June to September long period average, I'm getting this kind of pattern showing the jet, tropical easterly jet over our extreme southern parts of India. And then, likewise, this low level jet, 920 HPA wind, long period, 1981 to 2010, I have taken. When you plot, you see you are getting maximum wind speeds just off this Somalia coast. So, this is our low level jet. So, now let us first discuss about the subtropical westerly. This is a very important jet stream with respect to the winter season. It occurs at about 200 HPA level, around 30 degree north or south, like in both hemispheres it is there. And then it occurs on the polar limits of the Hadley cell above the zones of subtropical. Why polar limit? So when the Hadley cell forms near about the rising motion is over the equator and its descending motion is on the polar means when you move towards the pole, 30 degrees north or 30 degrees south on either side if you go, then descending motion happens around 30 degree north. So that is why the Hadley cell completes. So that in that region only this jet stream forms. It's geographically permanent and is more pronounced during winter. Just now I told you the reason why it is more pronounced during winter. The subtropical jet is caused with a concentration of horizontal temperature gradient below the jet level and reversal of the gradient above the jet level. Just now we saw how it is, how the blue and red color reverse after the beyond 200 HPA level. At and near the jet level, the temperature gradient is near about very negligibly small. And then small segments of jet streams where winds attain highest speeds are known as jet streaks. This also we discussed. So now during northern hemispheric winter, this subtropical westerly jet stream is seen in the south of the Himalayas. So I am showing you the picture here. You see, this is 200 HPA wind based on long period climatology, 1981 to 2010. And what period I have taken? November to January. That is the peak winter months I have taken. December, I have taken December as the center, so November to January. So here you see now the wind speeds are this green are all 40 knots. This just below this yellow. This yellow 50, then this dark yellow means it comes to 60 knots. So here you see these are all the strong wind speeds. And where do you see these wind speeds? Over the northern parts of India, the south of 30 degree north. It is between November to January. Then I'm showing you another picture, June to September. The same winds over the same region. But where do you see the maximum wind speeds? Now 40 degree north latitude, we are seeing the jet streams. During the monsoon season, the subtropical westerly jet is not seen over the Indian region. It is seen to the north of the Indian latitudes. So here you clearly see here, along 40 degree north, you can see the strong wind speeds here. But here you see that these winds are coming from here. This is the jet here. So over the Indian latitude, something along the 27 to 30 degree north. So during winter season, the subtropical westerly jet stream is seen to the south of Himalayas over the northern parts of India. Its mean position is something like 27 degree north at 12 kilometers height. And there is downstream strengthening of wind speeds. That is from as you go from crossing from here on the western side Jodhpur. On the eastern side, you can say it crosses the Guwahati. So as you go over the Indian region, when from Jodhpur to Guwahati, if you go, the wind speeds downstream means what? As it moves in the direction of flow of the wind. So as the wind flows from Jodhpur to Guwahati, you will find the wind speeds increase. So there is downstream strengthening of the wind speeds from Jodhpur to Guwahati across the country. The jet continues further. It is not stopping with Guwahati. It is continues further northeastwards across China and Japan. And the wind speeds keep on increasing. You can see here how the wind speeds are increasing up to about 200 knots over Japan. But during the southwest monsoon season, you can see the subtropical westerly jet moves to the north of the Indian latitudes, approximately along 40 degree north. So whatever all these words, all these are in your notes. But these pictures I am showing you only for you to visualize. Are you able to see? This is a real situation. I have taken the actual data and plotted and showing you. Are you able to see?
Yes, ma'am.
Okay. So this is on any day you can see this. I told you every day chart this subtropical westerly jet can be seen, but its position may vary. So on a particular day, I'm showing you a 200 HPA level over the Indian latitude. This is in November. You can see here. This green is 60, this light blue is 80, and then this 100 knots. So here you can see 60, 80, 100 knots winds are there over the Indian region. Wind speeds are increasing. So this is actually subtropical westerly jet stream over something like say 25 to 30, around 27 degrees. You can say it is seen over the Indian latitude. during the winter season. That is, I'm showing November. It will happen in December, January strongly, but when I was searching, I got this, so I thought I will show. November is also the winter conditions only. And the jet starts coming over the Indian region. So subtropical westerly jet lies entirely within the tropical troposphere. Why? It is below the tropical troposphere, about 3 to 4 kilometers below the tropical tropopause. The jet is in the region of the break in the tropopause between the tropical and the mid-latitude tropopause. That is tropical tropopause is approximately around 16 kilometers, I told you, and then the mid-latitude tropopause something like 12 kilometers or 13 kilometers, you can say. So at the break between these two tropopauses, that is where you are having this strong horizontal temperature gradient. So that is where the jet stream forms. So jet is caused by concentration of horizontal temperature gradient below the jet level and reversal of the gradient above the jet level, and near the jet level the gradient is near about zero. Now subtropical jet is very steady. It can be seen daily on the charts. But it's actual every day it's slightly its position may vary. But it will be seen as a mean chart. It can be seen in the mean charts. Also I showed you 30 year normal also I will show that. So in the mean chart also you can see. The subtropical jet is located near the polar boundary of the Hadley cell. That is what the Hadley cell is ending now on the pole side. So there only you are seeing the subtropical westerly jet stream. And the deep troughs in westerlies, active western disturbances across India. When these kind of situations happen, no, when a deep westerly trough passes over India, or a western disturbance passes over India, or under that situations, what will happen? This jet stream, no, that will also move south of its normal position. So it's a deep troughs in westerlies and active western disturbance across India shifts the jet south of the normal position. But if you are having a ridge passing over the Indian region, then this jet will move north of Indian latitude. Generally, no, jet streams are very strong winds moving very, very fast. So they are not going to cause major weather as such. So generally clear weather. But on some occasions, where the region where there is greater divergence, just below that if there is a system, then that system intensify and give rainfall. So on special occasions that could be rainfall, cloudiness and rainfall. So this is you can see here this picture now we not going to all this. Just you keep this is jet axis. Winds are coming from west to east. This is the direction of the wind flow. So this is the where you are having maximum, jet maximum. So around that you draw two iso lines here. Isotach analysis, I don't know. You will do it when you practically do, you will see. So you just draw this maxima region. So at the right entrance, when the air is entering from here to its right, there is divergence. And then when it is leaving to its left, there is divergence. On the other sides, they are having convergence. This is in the upper level. So at the right entrance and the left exit, there is divergence. Associated with this divergence, if low pressure systems are seen just below the region of divergence, then they may give rise to intensification. Otherwise, there may be well-marked weather and intense thunderstorm activity also. During when they are having western disturbance or something, and you are having this jet is going means, and then some little bit of instability is there, and then this divergence also that means it will lead to thunderstorm activity. Next is the polar jet stream. So, like we saw how this subtropical jet is forming between the Hadley cell and the Ferrel cell. So here again over the polar cell, between the polar cell and the subtropical jet stream also there is another jet stream known as the polar jet. So this is associated with the boundary between the high latitude cold polar cell and mid latitude Ferrel cell. It can also be seen as a daily charts, but not like at the same height as in the subtropical westerly jet. Subtropical westerly jet stream, I told you, around 200 HPA level. But this is at a lower level. Because you see, the heights are all very less. As you go towards the pole, the temperatures are very, very less. The height of the air column is also less. So the tropopause is at a lower height. So you will find that these jet streams are at a lower heights, say about 400 to 300 HPA levels. The average position of this jet stream also changes seasonally. Like as the sun moves southwards or northwards, all the pressure and wind belts will move. At that time, this jet will also move southwards or northwards. So its winter position tends to be at a lower altitude and lower latitude than during the summer season. And the longitude, lower latitude means what? Instead of say 60-degree north, it could be 50 or 40-degree north, like that. So latitudinal position of the polar jet stream varies considerably on the daily chart. It moves equatorwards and poleward. Generally, see the variation. 40 to 70 degree north. That is the variation. Because north-south temperature contrasts are greater in winter season than in summer season. The polar front jet stream winds are faster in winter. That is what wind speeds are faster means what? The jet stream is more stronger or more intense during winter than in summer. The reason is the same for subtropical jet as well as polar front jet. Because the temperature contrast is more during winter than in summer. Jet streams are also stronger in winter than in summer. Then the other jet streams, just to recall, during the monsoon season, you have a 200 HPA level north of our Indian latitude, approximately 40 degrees north, you have the subtropical jet stream, which during winter season comes over Indian latitude, but during monsoon season, it is to the north of our Indian latitudes. But to the just along the extreme southern boundary of the Indian latitudes, to have the upper levels of 150 HPA level, the tropical easterly jet. So this is another important jet stream which we discussed in detail when we discussed about during the monsoon season. It is seen only during this season and it is not seen over any other part of the world. It is associated with active monsoon conditions, but during weak monsoon conditions, this jet will move northwards. If it is moving southwards, it moves southwards during active monsoon conditions, northwards during the weak monsoon conditions. And then these things are what we discussed during monsoon season. Same thing only I have put here just to recall. During monsoon season, how intense heating there at the end of the northern India compared to south gives rise to horizontal temperature gradient, which will give rise to easterly thermal wind. This easterly, the general flow is westerly, but the thermal wind is easterly. That means what? The thermal wind is opposing the normal flow. So this thermal wind actually, because it opposes, it will reduce the wind speed, westerly wind speed. So at the lower levels, it will reduce the westerly wind speeds, and then upper levels where there is no monsoon flow, the winds are all easterly. This thermal wind will add. So the net wind speeds keep on increasing at 150 HPA level. They will be very strong, and then they become the tropical easterly jet. And their location is along 13 degree north, roughly along Chennai latitude at 150 HPA level. It is an accelerating stage from Vietnam to Peninsular India, and thereafter it is a decelerating stage from Peninsular India to western coast of Africa. And this we discussed earlier during during active monsoon conditions, it is located south of its normal position. But during break or weak monsoon conditions, it is seen to the north of its normal position. Sometimes it may two maximum may also be seen. So this is the tropical easterly jet. You can see here at 150 HPA level wind speeds. See here. Here wind speeds are increasing. This light shades of yellow, darker shade, and then orange, red, brown like that. So light shades of yellow, darker shade, orange, yellow, red, brown like that it goes. So wind speeds are increasing here. Then beyond that, here you see now red, orange, then lighter shades, and then yellow, so different shades. So here wind speeds are decreasing. These are all not in meters per second. 30 meters per second means what will be the wind speed in knots? Can you guess? Do you know the conversion from kmph to knots to meters per second, or is there any ways? Yes or no?
Almost 64 knots.
Pardon?
It's around 64 knots.
Approximately, that is, you say, if you give the wind speeds in meters per second, you have to double it for knots. And then for kilometers per hour, one more doubling is required. Okay. So that is approximately. So here 30 means something like 60 knots we can tell. This is the 30-year average. On any particular day, the actual value will be very high. So next is this cross-equatorial flow of the low-level Somali jet. During the monsoon season, you see which we discussed. You can see here off the African coast how the wind speeds are sharply increasing, becoming low-level jet at surface level and then 925 HPA level. At 825, wind speeds decrease. It is only in the very low levels it is seen. That's why it is called a low-level jet. This is another cross-equatorial flow which is giving us to jet, because it is not satisfying to a WMO definition for jet, that is 60 knots. It is less, but for low level wind it is very, very strong. That's why we classify it as a jet stream. Just a minute. Literally. Stage one, I'm checking. So I told you here there's very sharp heating, extensive heating over Somalia give rise to heat trough. That is heat low, like monsoon season, no? Like how it forms, that heat low is forming here. So this heat low gives rise to sharp temperature contrast. This gives rise to strong tightening of the pressure gradient, because of which wind speeds increase. That becomes low level jet. So this is also known as the Finlayter's jet or Somali jet. This strong southeasterly trade winds, after crossing the equator, they become southwesterly due to Coriolis force, become strong and become low level jet. And then generally known to the positive vorticity and convergence are seen to the north of the jet core. Gives very good rainfall and along the west coast especially. So that I think completes the topic on jet streams. If you have any questions, we can discuss. Otherwise, we shall stop here. Could you follow what I discussed? Very important. Winter season, jet streams, southwest monsoon. Very we can choose 4, 5. If you see the past question papers, for 5 or 6 important big questions will come from these topics. Could you follow what was discussed?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, then we shall stop here. And the next week, we shall see some elementary ideas about impact-based forecasting. I'll just discuss. Not much is required. Just I'll give you a idea. And then after that, any more discussions, any topics, if leftover is that, we note and bring, we shall discuss. See the syllabus, whether we have completed everything, then we shall discuss in the next week. Otherwise, I think my portion I have completed. Only that impact based and small little bit of short range forecasting. Some discussions we can have next week. That's all. With that, it will be. So we shall stop here and continue in the next class. Thank you all.
Thank you, ma'am.